Hello everyone and welcome to another AB Computer Science video. In this video we're going to begin a new topic which thankfully is just an extension of something we've already seen. We're going to be talking about multi-dimensional arrays in Java. And we've seen arrays as a collection, a data structure that allows us to hold data in a meaningful fashion. But we've seen arrays basically as lists. They have their limitations. We know that they have a specific size when they're created. They can only hold one data type. and we can't resize them, so those are limitations. But the extension of that idea is still important because really one of the goals of arrays is to maximize how much data we can store without having to have endless names of variables and things like that. And so when we take the idea of a single dimensional array, which we don't usually say one dimensional, we just say an array, and we expand it to say, well, could we hold more data, and if we wanted to, how could we do it in a way that's easy to manage? And the answer is multidimensional arrays do exist in Java, and we can kind of expand. We're only going to look at two-dimensional arrays, and those are usually easier for us to get our brains around. But the reality is the number of dimensions is arbitrary, and we really could go crazy with how many dimensions we needed. Now, if you start doing more than 2 or 3, then maybe your planning design could be restructured. Classes and class design, object-oriented design might be a better approach than making multi-dimensional arrays that are over maybe 2 or 3 dimensions. So it really depends on what your goal is. But either way, we'll continue here with some examples. Let's go back to our array stuff package. We already have our one-dimensional array examples. Let's go ahead and make a new class, and we'll call it multi-dimensional arrays. Right? So there's our class, multi-dimensional arrays. Now, again, we're going to stick with two-dimensional, and essentially, if you think about an array as a list of single items, the way we access information in that list, there's one variable name. So we might call our array, items or numbers. And the way we know that there are multiple items and the way we access each item is with an index. We talked about how, it's zero-based indices, and if you give a number, it finds that spot in RAM in relation to the starting point. So if I say index 4, I mean the 5th item, and so on. And so we're going to expand on this and say, well, if we have more than one dimension, instead of being a single array, one view of it is, instead of being a single list with one index to refer to a spot, is you can imagine it kind of like a grid or a table, where instead of one row, there's actually multiple rows, and every row has the same number of columns. And so if that were the case, for example, like in Excel, it's a giant grid. What we typically need, and in Excel it's a great example, you need the row value and the column value. So in Excel you might say something like A5. A is the first column, 5 is the 5th row. And so the idea that you need 2 pieces of information in a grid to find any one value is the same logic we're going to apply here. When we make a two-dimensional array, what we're saying is, in order to find a value in this collection of values, we must give it 2 pieces of information. And what you call those things is kind of an arbitrary thing. We might call them the row and the column. We might call them the X and the Y. We may call them the I and the J. There's kind of an endless supply. The most common is which row are you on and which column are you in. That's one point of view. Another point of view, and the one that's more accurate to the actual representation in the RAM of a computer, is to say a two-dimensional array is an array where the values are arrays. So it's like a list of lists, an array of arrays. And then in those secondary arrays, that's where the data type values are. So for example, we're going to do this for our first example. So how do we declare a two-dimensional array? So we'll make our main, and we'll set this up. I'm going to make an original one-dimensional array, and then we'll jump into a two-dimensional array. So if I wanted to keep track of a single-dimensional array of numbers, I might do something like int brackets numbers. And that's a variable that will refer to a one-dimensional grid, or a one-dimensional array of values, int values in particular. And so there's the declaration. We would initialize it potentially like numbers is equal to a new integer array. And of course, we'd have to give it value. So in this case, I'm saying this array can contain 10 values, right? So now the equivalent. So for a two-dimensional array, or for any number, any multi-dimensional array, we must use bracket notation to specify how many dimensions there are. So in a one-dimensional array, we've done it by putting 1. And it's as easy as the more bracket sets you add, the more dimensions there are. So here we go. We're going to make a two-dimensional array. So I'll say a 2D array. And again, I'm going to put it in words because, again, it's often useful to see it in this way. This is like saying an array of arrays of integers. And I know it's kind of strange, but this is what we're saying. We're saying this array we're going to create is an array that contains arrays that contain integers. And that's we've amplified how much data we can hold. And so how would we write this? We would say int bracket set, and then another bracket set, and then our name. And I'm going to call this one grid. And so there's our declaration. And so again, one of the things that we had talked about when we did one-dimensional arrays is that these brackets could technically be put on the end of the variable name, even though I personally think it doesn't look very good. And one other reason I think it's better to do this is because it reminds me this is not a single int, but an array of ints. And so we're saying here this is an array of arrays of ints. So this two brackets says, hey, this is a two-dimensional array or an array of arrays that each of those subarrays contains integer values. And again, there is no limitation on the data type. I use ints only because it's convenient and easy, but this can be an array of strings. This can be an array of bank account objects, an array of student objects, of scanners, of any class type that we create or the Java people create. Really, there's no limitation. But in this case, we're making a two-dimensional array of integer values. And to declare it is the same thing, except now there are 2 dimensions that must be given a value or size. We need to know, well, how big is the array containing all the other arrays? And then how big is each subarray going to be? So we're going to say grid is equal to a new 2D array, and we'll say something like 3, and then we'll do 5. And so now ask yourself, based on this construction, how many actual integers are there going to be? And the answer is 15. How do I know it's 15? Because what we're saying is the grid is an array that contains 3 arrays. And each of those arrays contains 5 ints. So if there's 5 in the first one, plus 5 in the second one, plus 5 in the third one, that's 5 plus 5 plus 5, which is 15. So just in one variable, we actually can contain 15 integer values crammed into one. Now, could we have made a single dimensional array with 15 spots? Sure. But one of the other advantages is that instead of only thinking of it as an array of arrays, if we think of it as a kind of like a table or a grid, we could kind of argue that, well, things that are in the same row have some connection, and things that are in the same column have some connection. And so it's very convenient to come up with this idea. But this is up to you and your situation and how you want to visualize it. When it comes to drawing it on paper, a grid is a very convenient way to do so. But if you're talking about like collections of collections, then thinking of it that way is often better as well. It really depends on what your goal happens to be. And so assigning to an array a two-dimensional array or a multi-dimensional array is the same as a single-dimensional array, except, of course, since there are now rows and columns, we need 2 data points. We need to know which row and which column, or which subarray and then which value in that subarray. The idea is that we need 2 pieces of data in order to find any one value within the grid of values, right? So assigning to a 2D array requires 2 indices to locate any one value. And I'll just generalize, and if we have a 3-dimensional array, then that would take 3 data points. A row, a column, and maybe like a depth, or an x, a y, and a z. right? You need 3 pieces of information to find any one value. And if it was 5-dimensional, then you would need 5 indices to establish that. Now, how do you visualize a 5-dimensional container? That's maybe beyond typical people's visualizations. 4 dimensions is kind of hard. But really, what we're saying is, do you have 5 pieces of information in order to map to one value? And that's what we're doing. And so a 2-dimensional is pretty easy for us to manage. And again, if you go beyond 3, often it's not that helpful. But it is allowed. So here we go. So for example, if I wanted to make the first row second column, then I would have to use, so I'm going to go ahead and say, let's fill in first row second column. The terminology we might use is what's called row major order. That says that typically the first value is the row you're in, the second value is the column. So if the first number, when I say first row, that's what the first index is. When I say second column, that's what the second index is. So to assign to the first row and second column, I would say grid at, which is our bracket notation. First row, both arrays are 0 base index, so the first row would be index 0. And then second column, so the second column would be index 1, because it's always off by 1. And then I'm going to assign a value, so let's put the number 100 in that spot. And so again, in order to map to one location, we must access 2 data points. What row are we in? What column are we in? Or again, you could also say, well, which array are you in? Which subarray are you in? And then within that array, which index are you at? So go to the first spot, or sorry, the second spot of the first subarray. Right? There's kind of no, which way you makes more sense to you is perfectly acceptable to pick. And then let's do one last simple example. Why don't we say, I want the last row and the last column. And again, I could cheat by using these numbers, but let's say I didn't know how big it was, how many rows and how many columns. We could use the same logic that we would use for a 1-dimensional array. If we don't know, we do know there's a property called length that gives us it. So I could say fill in last row, last column. Right? So I'm going to generalize. And I can say grid at grid.length. That's how many subarrays or rows there are. And of course, we have to do -1 because if there are 3 rows, then we don't want to say go to index 3. That would be the 4th row. We have to do index 3 - 1 or 2. And then in this case, now this is a little bit harder. If we want to go to the last column, we know that each grid value, the initial grid value is an array which has its own length. So every grid has an array and a length. And so that means we'd have to say, well, go to one of the rows and get its length. So let's make the assumption of the first one. So we'll say grid at 0, which is the first array or subarray, dot length. Now again, I'm making an assumption and I'll point it out here. Oh, sorry, we have to do an assignment. So let's assign this to the number 100 as well. The assumption I'm making by doing this is that our array is not jagged. And so what does it mean to be jagged? And I'm only going to mention it because it can happen in Java and you're allowed to do it, but on the AP exam, thankfully, we are never going to deal with jagged arrays. Right? Jagged arrays, and I'll write it down as a note, jagged arrays. Right? The idea of a jagged array is where each subarray does not have the same length. So you can imagine, like, if you make a table in Excel, right? Or actually, let's just say just a table in general. Typically, every row has the same number of columns, but that's not true in Java. We're allowed to make subarrays or rows that have differing numbers of columns, which could be bad, could be good. We have to kind of accept that, but we don't have to worry about it. You will never be questioned about that on the AP exam. They always tell you may assume it's rectangular. So the opposite of a jagged array is a rectangular array. Right? It does not mean that there's the same number of rows as columns. Instead, it means that whatever number of columns there are, every row has that many. So if there are 7 columns, so and again, in this example, we're saying that there are 3 rows and they all have 5 columns. There's no mixing and matching. Right? Again, if you needed to, you could make different length subarrays, but the reality is we're not going to do that for the AP exam. So we'll say, I'll just write down jagged arrays, or jagged 2D arrays. It basically means the subarrays within the 2D array are not, or do not, let's say, do not have the same length, right? Which again, we won't have to worry about in this. So that means that whether I said grid at 0 or grid at 3 or grid at whatever, every one is going to have the same length. So it really doesn't matter which one I pick. Right? In this case, it would be 5. So, or index 4 minus 1. I forgot my minus 1. So it would always be safe to use no matter what, whatever value I picked, as long as it's in range. The same rules apply for index out of bounds exceptions. If I use a higher index than there are items to use, length are larger, then it's going to cause a problem. And so there it is. I mean, again, the idea is like the harder part, I think, is when would you use a 2D array? And I'll do an example in a moment. But the reality is that the creation of 2D arrays, the assignment, the accessing is the same logic that we might do for one-dimensional arrays. It's just now we have 2 steps to take. And so the bottom line will be, if we used one loop to fill in arrays or access single-dimensional arrays, we're going to probably have to use 2 nested loops to look through a row and column. So that's the only real kind of big leap we're going to make. And so now let's go ahead and try doing that. Let's print out the contents of our array. So here we go. I'm going to say, let's go through every single row. And I'm going to use I and J, and actually I'll maybe not use I and J instead, because sometimes what people like to do, and this is a matter of style, is they use R and C, right, for rows and columns. Or you can even use the word row and call, or row and column, whatever you think is appropriate. I mean, I often would use I and J just because it doesn't matter what you call them, as long as it's obvious which row and column are in. So I'll go ahead and do R and C for this one. So we'll say R starts at 0. And again, remember, we are still using indices, so I am going to start with 0 because the first spot in any array, one dimension or more, is index 0. As long as R is less than grid.length, which again is saying the number of arrays in the grid array. Right? Because if it's an array of arrays, we're saying how many arrays are within this one array. Right? Or you can also interpret it as how many rows are there. Row major order says rows are first and then columns. Right, so we'll say row major order. We're going to assume the first value, the first index is row positions. And the second is column positions. Okay. And then, of course, we're going to go up by 1 each time, so R plus plus. So there's our thing. We're going every row. Now, within each of these rows, that's not enough information. R could not fill in 2 indices, so we need to have which column are we in within row R. So if R is 0, well, which column in row 0? Right? If R is 5, which column in row 5? And so another loop would be really helpful in doing this. So let's make another one. We'll say for in C equal to 0. C less than, and now here's where I mentioned again where this is kind of convenient. I might say grid. And now, could I put 0? Yes, because I'm allowed to assume that it's rectangular for the AP exam. But if you want to make code that's flexible, AP exam or not, then what would be a good choice is which row are we in? We want to look at the columns for the row we're in. So we're at position R, whatever row R is, and then dot length. Now again, we are allowed to assume that the grid at any position is the same length, but if it's not, this would handle it one way or the other. For the AP exam, they won't try to trick you with jagged arrays and things like that. And then we can say C goes up by 1 each time. And now, if we're here, we're at row R and column C, whatever numbers those happen to be. And in other words, we need to go through every column before we can move to the next row. Right? And so that's one way we're doing this. And of course, what I'm going to do is I'm going to print them out. So I'll do system.out.println. And I won't do the ln because I want them next to each other. So we'll print out the value. We'll print out the grid at R and C. And then we'll attach a space after it. And then after all the columns are filled in, then we'll print out a new line character so that the next row will end up underneath it. And so this is kind of like how we did the example of the multiplication table when we did the first time we saw nested loops. We're basically using nested loops, but now we're accessing an array. So what I'm going to say is we should see all zeros except for the second column of the first row, so the second value, and then the last, which is going to be the third row in the fifth column. We should see 100. So that's what I expect to see when I run out and print grid. So here we go. And there it is. So there's the first row. Notice the first value is 0, the second value is 100, the third, the fourth, and the fifth. Notice there's 5. Again, it's not spaced out evenly, but there are 5 values. There are 5 values. There are 5 values. How many rows are there? 1, 2, 3. How many columns? 1, 2, 3, 4, 5. So that's what we're saying when we make a two-dimensional array. Again, a table or a grid is a really easy way to visualize it, but also talking about an array being a 2D array being an array of subarrays is another convenient way of discussing it. So I'm going to stop the video here, and we can continue in another video with some examples of this. I hope that we see that in reality, nothing that we've done is particularly different from one-dimensional arrays. All we're doing is adding a little bit of complexity by saying, well, arrays can contain any value, and in fact, it's so flexible that the values that it can contain are other arrays. And so the idea is that it's really important to, and actually I realized there's one more thing we should do in this video before we stop, and this will hopefully make it a little more obvious that it is an array, a 2D array is an array of arrays, and so I'm going to do this now. I forget, and so it's good that it popped into my head. Literal arrays, we've done this before. Let's make a single-dimensional literal array. We've done this before. So we'll say something like int array literals equals, and then again, to do a literal array, we put it in curly braces, and we might put the numbers in order. So 1, 2, 3, 4, 5. And there's our literal array. But in fact, for any dimensional array, two-dimensional, 3-dimensional, 5-dimensional, 1,000,000 dimensional, though I don't know how it would be managed, we can create a literal array. And so here's how we might do it. We might say int two-dimensional array, and we'll call this, we'll call it 2D. Oh no, we can't start with the 2, so let's call it, call it matrix. And we'll say is equal to, and so I'm going to start off with my literal array. There's my literal array. And now what's inside of this literal array? Not integers themselves, but arrays of integers. So let's make 3 subarrays that each have 3 values. And so I'm going to make another set of curly braces, and I'm going to say 1, 2, 3. And so now if I were to ask you, what does this 2D array actually consist of? It's an array that contains one array. So there's 1 row, 3 columns. So if we had to say the number of columns, the number of rows and number of columns, this would be the same as saying 1 and 3, right? Because there's 1 subarray and there are 3 values or columns in it, right? So I would say this looks like new int 1. Oh, come on, there we go, 3. Right, that's how we might construct it at empty. Now this is literal, so we're not putting empty, but if we did this, it would be the same thing, right? And so if I did another one, if I said matrix is equal to, and I did it again, and I said, oh, are we not allowed to reassign literals? Oh, let's try this. Oof. We might not be able to do it, but let's try it. 1, 2, 3. Oh no, we're not going to be able to. I guess we can only do literals in the first time around. So let's edit this one. So again, I put this here, but I'm going to change it. So, and then I'm going to put a comma, and I'm going to do it on purpose on another line. Actually, I'll do it right here. I'll put another array, and I'll put 4, 5, and 6. And so now, what would this be? This would be an array that contains 2 arrays, where each of those arrays contains 3 columns. So this would be a 2 by 3 two-dimensional array. And I'll do one more, and I'll say another array, and we'll say 7, 8, 9. And so this is a 3 by 3 two-dimensional array because there are 3 rows with 3 columns each. And now what I'll do is, to make it visually appealing, I'll do this. And then maybe this becomes more obvious what we're trying to express in our two-dimensional array. And there it is. Right? Oh, I should put my spaces to make it look consistent. And so this is an array, that's the outer brackets, the outer curly braces, and then it contains 1, 2, 3 subarrays or 3 rows, and each of these contains 3 columns or 3 values. Now, this is rectangular. Now, when I talk about jagged, for example, this would be allowed, even though the AP exam wouldn't do it. Right? The first subarray contains 3 values, the second subarray contains 2 values, and the third array contains 3 values. Right? That could make our code harder. This would still work. This code here would work, but things like this, assuming how many rows there are and columns there are, could cause a problem. And so this kind of thing will not happen on the AP exam. Will it happen in real Java? Perhaps. It depends on what people are trying to do. But generally speaking, the AP exam will not ever do that. So there's a literal representation of an array of arrays. And in reality, we could do three-dimensional. It would be ugly, but we could do it. You would just put more curly braces and more commas. It would be an array of arrays of arrays. And this idea can be expanded arbitrarily. So now we'll stop the video. We'll continue with some examples of two-dimensional arrays and go from there. So I'll see you in the next video.